Crystallization starts by gradually cooling the crucibles in order to create multi-crystalline ingot blocks. To produce multi-crystalline wafers, multi-crystalline ingots are first cut into a predetermined size. The ingots are then individually tested before cutting in order to confirm the quality of the ingot. The multi-crystalline ingots are cropped to remove impurities. To ensure maximum quality, the surface of the ingot is then polished and the edges are grinded. Finally, the usable parts of the ingots are sliced into wafers by wire saws using high-precision cutting techniques, which utilize steel wires and silicon carbon powder. After this process, the wafers go through a cleaning procedure to remove debris from previous processes. Trina Solar has developed exceptionally strict testing procedures. Since wafer quality is a key factor for cell and module performance, Trina Solar wafers are closely examined as part of the quality control process. In the next step, the wafer surface is treated in the wet bench. Wafers are placed in various baths for cleaning, etching, and rinsing. After completing the surface treatment, the wafers are dried by hot air. In a further processing step, a negatively charged coating is applied to the positively charged wafers in a diffusion furnace at temperatures ranging from 800 to 900 degrees using phosphorus gas. The phosphorus atoms diffuse into the wafer surface, and, as a result of such doping, the surface changes from positive to negative. After edge insulation, in order to reduce cell reflectivity, the cell is coated with a layer of silicon nitride, giving the cell its blue color. The hydrogen contained in the silicon nitride also significantly enhances cell performance. Contacts made of silver paste are screen printed onto the front of the cells to act as a conductor for the electricity generated by the cell. The contacts are subsequently burned onto the cell in a firing furnace. The high temperatures cause the silver to become embedded into the surface of the silicon layer, forming a reliable electrical contact. The completed cells are sorted according to efficiency levels and optical criteria. Each cell is assigned to a performance and quality class. To assemble solar modules, we interconnect multiple cells by taping and stringing the cells into the desired electrical configuration. The lines of cells are laid out and then assembled between glass, EVA, and a backsheet. The module is then laminated in a vacuum and cured by heating. An aluminum frame and a junction box are then attached to the laminated module. As part of our quality process, all finished modules go through a series of tests before they are packaged. Using an infrared camera, the first test screens for micro cracks at the cell level. The module is then flash tested as a final test of quality. Modules are then packed in environmentally friendly packaging. Our unique packaging also protects the product in transit by reducing the inherent stress on the modules. At Trina Solar, we run a series of tests on randomly selected modules. The first is a mechanical loading test, in which we determine the resistance of the module under harsh wind, snow, and static loads such as ice. Our modules are also tested for resilience in the event of heavy impacts. The test simulates an installed panel on a tiled roof or facade. Each part of the panel can be tested. At Trina Solar, we have also developed proprietary tests such as the Highly Accelerated Stress Test, also known as the HASS test. This test helps us understand how materials and components change over time. In turn, this allows us to confidently offer our customers a 25-year power warranty on our modules. We also use an infrared test to analyze the temperature of the modules when operating under the sun. Our modules go independent tests have recognized Trina solar panels as one of the world's top performers. Such are the tangible results of our state-of-the-art internal testing laboratory. Combine this with one of the most competitive cost structures in the industry, and you get the best solar value. Only by matching an efficient cost structure with proven performance will we, as an industry, achieve grid parity.